Welcome to The Explainer. Today, we're breaking down a really cool case study on how a team of AI engineers took their agent's memory from just okay to truly impressive. And it all kicks off with a problem that's actually pretty funny. So, get this. This quote is from the CEO of a company called Mastra, and it's hilarious, but it's a real problem. His AI assistant got totally confused because he talks to it about his kids all the time. This is exactly the kind of memory mix-up that developers are fighting to solve.
And that right there is the heart of the challenge. What is AI agent memory, really? And how do we stop it from thinking a tech CEO is a 5-year-old who's into stuffed animals?
Okay, so at its core, agent memory is all about digging through a long history of conversations. It's kind of like having this giant box of puzzle pieces from dozens of different chats. The AI's job is to reach in, find the exact right pieces for this very moment, and put them together to see the whole picture. It's not just about remembering stuff. It's about remembering the right stuff at the right time. You know the saying, you can't improve what you can't measure. So, to get serious about fixing this memory problem, the Monster team used a specialized test, a benchmark called LongMemEval.
Now, this isn't just some simple pass-fail test. It actually digs into 5 totally different types of memory. It checks if the AI can pull out basic facts, if it can connect the dots between different chats, if it understands time, if it can update what it knows, like realizing the CEO is not, in fact, a Squishmallows fan, and even if it knows when it doesn't know something.
So to handle all that, their system really relied on 2 main kinds of memory. First, you've got semantic recall, which is basically a super smart search engine for the entire chat history. And then there's working memory. Think of this like a little notepad or a set of sticky notes, keeping track of the most important up-to-date facts.
All right, so the team gets their system ready, they run it against the benchmark, and, well, the initial results were a little underwhelming.
They clocked in at 67%. I mean, it's not awful, but the state-of-the-art was sitting at 72%. That's a 5-point gap. In closing that gap, that became their obsession. They knew they could do better.
So the big question is how they do it. And here's the thing. It wasn't some magic fix, no silver bullet. It was a careful, step-by-step process of just grinding it out and improving one piece at a time.
They broke the whole problem down into 4 key areas, and they went to work, implementing 4 very specific targeted fixes. First up, that working memory, the sticky notes. See, at first, they were using this one-size-fits-all template to store facts. The fix was to create custom-made templates for each type of question. It was way more precise, and boom, accuracy went up right away. Okay, fix number 2 was all about how they updated those sticky notes. Before, every time new info came in, the AI would just scrap the old note and write a whole new one from scratch. You can imagine how that could cause problems, right? So they switched to a more surgical approach. Now, it only updates the one little piece of information that actually changed. Much cleaner, way fewer errors.
Then comes fix number 3, and this is one of those classic developer facepalm moments. Turns out, there was a bug, a really simple one, that was feeding the AI messages with the wrong dates. Can you believe it? Once they squashed that bug, the AI's ability to understand when things happened got a whole lot better, as you'd expect.
And for the final fix, they looked at the data structure itself. Instead of just giving the AI this long, messy, unstructured list of messages, they started organizing it. They grouped messages by day and added specific timestamps. It sounds simple, but giving the AI that kind of structure made a world of difference in understanding the flow of a conversation.
All right, so with all 4 fixes in place, it was the moment of truth. They ran the benchmark again, and the results, well, they didn't just get a better score. They learned something pretty fundamental about building these systems.
So check this out. It all came down to this one little setting called top_k, which basically tells the memory how many search results to look at. When they set it to 5, bam, 73%. They'd officially beaten this state-of-the-art score. They pushed it to 20 and eked out a tiny bit more to 73.5%. But here's the really interesting part. Look at the single session score. It's pretty much the same across the board. That tells you all their hard work was specifically improving long-term memory, which is exactly what they set out to do. It just goes to show how one tiny configuration tweak can be the final piece of the puzzle.
So when you look at the whole story, the real hero wasn't any one of those 4 fixes. The real winning formula was the process itself. I love how the team put it. The loop that leads to improvement is to build a test and then just iterate a lot. And that's really the big takeaway here, isn't it?
Real breakthroughs don't usually come from a single flash of brilliance. They come from that grind, that cycle of measure, test, iterate, and repeat. Which brings us to the final thought I want to leave you with. In whatever you're working on, what's that one key metric that you should be obsessively iterating on right now?